So good early morning, 2 a.m. We are a Vancouver-based company. I'm the founder. My name is Peter Sobotka. This is my third business. We spend about $34 million to make the company profitable for this year, next year, and year also, afterwards. We are a fast-growing company, and we are focused on digitalization of the grid. So let me. Oh, this is not working this way here. Okay, let me explain you the problem we are facing. In the European Union, on average, there are 100 households on a secondary substation. And in many parts of the world, there are many more households. Now, on every household, there is electric vehicle, battery, and photovoltaic, and house itself. So there are 4 loads which are generating or providing electricity. So if there are 100 households and these 4 components on each household, how many connections you can get on every secondary substation? 100 on power of 4 is 100 million. So 100 million is a challenge of how many devices we will need to somehow manage once the grid will become saturated. It's not only a matter of energy utilities, it's also a matter of electric vehicles, connectivity of the charging stations, and batteries, and so on. So where Corinex product sits, what we developed are so-called grid nodes. So Corinex grid node is a device which is using broadband power line technology. We are providing operating system and also connectivity of all these grid nodes, which are installed in the millions of the units. Our first customer, E.ON in Germany, I think current installation after it will be fully deployed will be about 800,000 nodes. This is the second phase of the mass rollout. This technology is also being deployed in other German utilities. About 70% of the German market is currently in different stages of using this type of the product. So grid nodes is having special 2 features. One is it is communicating at a very high speed, and it is having also processing power. It not only communicates, it is collecting electric characteristics from the grid. So it is collecting voltage, signal-to-noise ratio, carrier frequency response, temperature, phase angles, harmonics of the current, and so on. So we will get a lot of information about the asset, main asset of a utility, about the electric grid. So the difference of this technology with the other technologies is availability, because as we know, electric utility is having access everywhere. So the coverage of the grid is, I think, is one of the most important things. The other one is security. So in order to have TLS connection, as you know, we are using your credit cards, for example, when you are paying, making transactions from the credit cards, you need TLS connection for security. So the same has to be implemented on the electric grid. Our software can keep open 100,000 concurrent connections. We can also collect 2 million data per minute. The other one is, as I mentioned, asset management. So you are getting characteristics from the grid. You have the knowledge what is happening there. The fire rate, the speed is very high. It's very difficult to compare speeds of technologies. There is always a lot of discussion. So how fast is, narrowband power line, how fast is LTE, depends on the place and so on. So in this table, we are using fire rates directly from the lab. So the fire rate, physical rate of the semiconductor is 1 gigabyte. In electric grid, it translates to 100 megabyte per second connection. Cost effectiveness, I will not go here to the detail of the pricing, but the cost of the node is somewhere between 100 and 200 euros. So you have to install millions of these nodes on the grid. Availability is a very tricky question, and it is very important to understand what is availability in your grid when you are using different types of the communication. So, for example, when you are having wireless, the typical, I would say, way how you are building wireless network is you oversubscribe the wireless network, which is perfectly fine in normal standard situation. There is no need to have a proper ratio. But there is something happening and there is some sudden event, then there is a storm of the data. And electric grid cannot afford to go black. You cannot have the run on the grid like you can have run on the bank will go bust, and well, nothing will more or less happen. But if the grid will go down, people can freeze. There is a life danger situation. So this oversubscription is not a good thing for the utilities, so they need to build their own networks. Some utilities in Europe, they build, and they are in the process of building 450 megahertz networks. But as we will see, I'm seeing in the future, including our customers, they started to deploy already broadband power line because 450 is simply not providing enough sufficient bandwidth. If you just remember my numbers, 100 megabit per second in the grid proven performance of the technology. So here you see in summary on the left side is average speed in the network of our customer, of E.ON during the time of RFP, and the network was installed before we got a significant contract over the year, and everything was tested. The similar technology is currently in first phase of commercial rollout in large Spanish utility. And on the right side is the second idea to remember about broadband power line. It is that we are supporting smart grid applications. Now, from the history of personal computer and smartphones that at the end, every device which has to develop fast cannot rely only on the performance and productivity of the vendor itself. So the smartphones or personal computers, they are having the open interoperable architecture. And that architecture is enabling the third parties to implement their own solution to such a silicon or for such a provider. Currently, what we see is if you are buying electric meter, this meter is installed for 15 years, and then you will go and you replace it. But such an architecture is not very flexible for the innovations on the grid. What we see, this digitalization revolution will need much faster pace. That is why Corinex created open architecture. Open architecture means where third parties can implement their own applications, their own ideas, artificial intelligence, data mining, and so on the top of Corinex grid nodes. So I think that is a very important aspect of technology. So how much this technology will be needed? This is our proprietary map. I call it the map of the pain. And it is a map which is based on saturation of the grid or of the countries with penetration of electric vehicles combined with installed photovoltaics, rooftop photovoltaics or distributed energy resources. And you see there are two dark spots. Dark spots are bright spots for Corinex because those are countries which need our technology most. One is Germany, one is Denmark. Denmark is also a leader in the green energy, but they don't have so much distributed energy resources as Germany. So the map, I would say, is testimony to what we see, is that as the pain will be coming, there will be more saturation coming, there will be more need for digitalization of the grid. There will be really digitalization. Our friends, our partners from E.ON, they spent 50 days in Vancouver to help to develop this technology, and I'm very, very grateful for that. These are more detailed data on different countries. So you see, what I was saying, it is here, testified residential solar power capacity 9.3 gigawatt in Germany, and electric vehicles 1.3 million. So Germany is in the forefront of this change, and this is why I think there is the most discussion about digitalization, and this is why we are in 70% of German utilities in Frankfurt, Hamburg, Berlin, and Netze, and of course E.ON. So how safe is to use this technology from commercial point of view? What is the risk? Is there any standard? So technology is standardized in ITU, in International Telecommunication Union, where every major technology was standardized. For example, DSL, 5G, and so on and so on. I am chairman of Broadband Power Line Task Force on behalf of Corinex. in Prime Alliance, which is a utility association and which is building application stack on top of a physical layer of the silicon. Last week, we kicked off EV charging station and EV V2G group in Prime Alliance as well, led by Intel, chaired by Intel, and Corinex is the vice chair. Already, also we are working with G3. During this week, there was ITU meeting in Geneva, where there is starting to be alliance. G3 Alliance is starting to work also with Corinex to create the hybrid standard of broadband power line and narrowband networks. So as you see, utilities, whatever alliance they have, at the end they will come, I believe, to understand that they will need broadband and they cannot rely on this digitalization revolution on operators. One testimony to validation of technology and its penetration is to have the vendor ecosystem. So we are standardized in every key organization, as whether it is utilities or in ITU. We are working with several service providers. Today, 3 out of 10 largest European utilities, 3 out of 10 are using Corinex products at a different stage, whether it is in mass rollout or in first phases of the validation. There are many other utilities, including 2 utilities in Poland. We are embedded in several meter vendors as technology, so we are a technology provider. We are not the metering company, to understand. We are the technology provider, Corinex inside. And there are silicon vendors who are working with us on either exclusive basis or we are combining our product together with their silicons. There are 2 consulting companies involved already to support broadband power line. One is IDC, and there is very nice IDC report on the industry, history, leadership, and so on, where Corinex is featured as a leader. And there is Deloitte, who is working on the white papers about the broadband power line narrowband hybrid networks. So as a summary, I will have some time for the questions. I would like to mention here, and remember this memorable day at 2 a.m., that the broadband power line will be everywhere on utility grid. If you a little bit remember the revolution of IPTV and internetization, so internetization needed digitalization. Digitalization equals broadband, equals high speed and the processing power. So I cannot imagine, and I don't think anyone can, how this digitalization of utilities will happen without broadband power line, without high speed, and that means also without Corinex. Thank you.